Hello everybody. Give me a second here while I work out some technical difficulties. I checked all these sources before, but it looks like something's gone awry. There you go. Okay, that looks good. This looks very weird. What is going on here? What the heck? Okay. Sorry, bear with me here. Having a issue with the webcam as well. Filters. Okay. Just gonna resize this real quick. I swear I'm more responsible than this. I checked all these things like 5 minutes ago and must have hit a key or something. Everything got all weird. Okay, that one's fixed. There we go. That's looking a little better. It's a little janky, but it'll be okay for now. All right, welcome everybody. Thanks for tuning in to the first stream. We're gonna be doing some code. I'm gonna be doing some chilling. Gonna be working on Descent Horizon. Guessing most of you guys don't know what that is, given the fact that this is the first stream that I've done. Well, first official stream that I've done. So, before we get into any of the code or any of that kind of stuff, I want to kind of give a little overview of what we've got, what we're working with, and yeah, show you guys what we're doing. So, Descent Horizon is a game that I've been working on, I want to say on and off for something like a year now. I started in, I think like May of last year, and I worked on it like super hard for like 3 months. And then I kind of got a little bit burnt out and worked on it on and off from there. But yeah, it started off with me going to like a barcade with my wife, and like we saw this old cabinet in the back, and it was like this old Atari Lunar Lander cabinet, and it had like the weirdest controls, especially for like an arcade game. It was like this. Let me see if I can actually find it. Let me try to look up an image so you guys know what I'm talking about. Um, Let me see, Atari Lunar Lander cabinet. Yeah, I think I've searched them up before, but it's something like this. And like the cool thing about it is like these controls here. Like if you can see, let me see if I can get a no. Let's ignore that. Just want to open the image. Let me see, open image, a new tab. There we go. So like it has this like thruster control thing where you grab the whole thing and you move it up and down. And I thought that was the coolest thing. Like you would control the thruster of the lander using this like this lever, you know. And that was kind of the whole thing. Like you can like turn the rotation of the ship, you know, left and right and that kind of thing, and then you're just, you know, fighting gravity on the way down. Um, so I played this game at the barcade, and I was just like enamored with it. I played it like all night. Spent way too many tokens on it, and then I couldn't stop thinking about it for a little while. It was just like at the back of my mind, and I wrote it down to like, hey, I want to build a clone of this one day, you know, and just like just to say that I did it, you know, because I thought it was the coolest game. But originally it was just like I want to keep it like a straight clone. Like, let me see if I can actually find a little YouTube video of the Atari Lunar Lander, just to show you guys what that game looked like. I'm gonna mute this so it's not super loud. But like basically, you're you're controlling this ship, right? And you're trying to land, and there's like certain spots where you can land. It's not just anywhere, you know. And depending on how hard you land, you get some points. You have limited amount of fuel, and like the amount of fuel that you start with just carries over for the entire run of the arcade playthrough. So like once you run out of fuel, that's it, and it just gives you your high score based off of like how well you did. Um, and so you're fighting like gravity on the way down, and you're just trying to land, you know. And so originally the goal was like I just want to make this. I want to make Lunar Lander on my own. And that by itself didn't seem like the that riveting of a project because it's pretty simple. You know, it's some lines, some colliders, and then like a little bit of physics. So I was like, well, like one thing I can challenge myself to do is just to do this without any game engine, you know, and you know, not use Unity, not use Godot, not use anything like that. Just go ahead and like build my own engine. And like for me, that was like that was kind of like the meat of it. It was the most interesting stuff, is I wanted to build as much of it from scratch because I figured then I can learn about rendering pipelines. I can learn about you know, physics and like collision detection and stuff like that. And I come from web dev. I don't come from game development at all. So for me, all of this stuff was new. Like I had worked on games in the past, but nothing like substantial, if that makes sense. Everything that I worked on, I worked on like one Unity game a few years back where it was like a multiplayer game of freeze tag that I never ended up releasing because like once I did the math of how many people I would need to have on release to make it viable and like playable, I was like, I can't do this. This is gonna be too much. Um, it would just require way too many people to all buy it at the same time, you know. Um, but you know, that being said, like I was pretty much entirely green to this. Aside from that one little experience with game dev in the past. Um, so that's kind of what drew me to it, was like, can I build an engine from scratch? Can I figure out the physics? And I'm not like good at math. I'm not a math buff or anything like that. Or physics for that matter. I was decent at physics in school, but it wasn't anything, you know, crazy. Um, so I was like, you know, let's do this. It's gonna be a challenge, and we'll see where we get from there, right? Um, so I that was the pitch, right? I'm gonna build this game, and it's gonna be a clone of Atari's Lunar Lander, and I'm gonna build a custom engine for it, and it's gonna be Atari's Lunar Lander, but with real physics. I don't know if I mentioned, but like Atari's Lunar Lander does not have real physics. Like it looks pretty convincing, right? Like the physics, the physics are physics, right? Like the lander falls and you control the lander and you can fire it in different directions, right? And but like as far as like physics goes, that's kind of it, you know? Because you have to remember this is 1979, it's an arcade game cabinet, and there's just not that much processing power that these things had. Um, so yeah, that was it. Like I wanted it to be Atari Lunar Lander, but with realistic modern physics using rigid bodies and all that. And there was one more little thing that I thought would be pretty cool to throw in there. So like Atari's Lunar Lander originally, the way that they built it, like all the levels are pre-made. So like these like mountains that you're seeing, they're hand authored, right? So like every time you play the game, you're playing the same levels in the same order. And that's great for like an arcade game, but like if you're playing a more modern game, it's not that common to have like for a game like this where you are just getting a high score. It's uncommon, or at least from my take on this, is that it's uncommon to just have like a set of levels to perfect, you know, especially if it's only a handful of levels. So I thought it'd be really cool to have the levels be like procedurally generated. So it's like, okay, Atari Lunar Lander with real physics and rigid bodies, and then procedurally generated terrain, so that it's different every time, and then like everything else can be the same, you know. Um, and I built that, and for a while it was that, you know, for like a week, that was what the game was. But then I kind of was like, I was really enjoying flying the lander around while I was doing all that testing, and like, you know, making sure that the game actually worked as a clone. And by the time I was like ready to be done with the clone, I just didn't want to be done working on the game. So I was like, what can I do to extend this? You know, can I turn this into something more? And so then I thought of like a whole storyline behind it, and thought of like ways to extend it. And before you know it, like it became like a whole other game. So like when you look at it, it's very obviously inspired by Atari's Lunar Lander. Like it is, you know, a like if like games that are like Dark Souls are called Souls likes, like this is like a Lander like, you know what I mean? Um, but yeah, so let me just go ahead and show you guys what this looks like. Like, keep in mind, uh, this is C++. This is there's pointers. There's a bunch of weird stuff that happens. So it's pretty possible that I'm gonna like run this and it's gonna crash a handful of times because we're in the middle of a pretty hefty UI rewrite. So let's see what happens. Da, 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 da. Looks like my technical difficulties from earlier want to persist. One sec. There we go. Okay. There's the game. All right. So, quick little run through. We can, well, this is just the options, right? These are not important. Nobody cares about these for the most part. But yeah, here's the game. So you start off just like in Atari's Lunar Lander, you're falling from the sky, and your main goal is to just like land, right? And you have this debris that's falling all around you, and you're trying to, you know, survive. So as these pieces of debris fall, you need to keep an eye out for them and move out of the way if necessary. But you make your way down, and you land on the ground. So like you see that one's kind of nearby. It's not going to hit me. It's not on trajectory, so I don't really have to worry about it too much. But yeah, so you manage your fuel, right? There's a certain level of fuel, and I got hit by that one. There's a certain level of fuel that you have, and like as you burn fuel, the fuel burns, right? Like obviously, you can control your throttle. So like I can increase my throttle. It burns the fuel faster, but like I also, you know, have increased upward force. I can decrease my throttle, and it'll have less force. It'll burn the fuel less quickly. You also have to manage your RCS thruster fuel, and that's like the fuel that like is used for turning, like your rotation and stuff like that. So there's that, and then there's a whole like crafting system and stuff like that I'll cover in a little bit. But like this is kind of the crux of it, right? Like you deploy the landing gear, and then boom, can I land? UI looks really rough right now. Obviously, there's like some things that are like off-centered and misaligned. This is actually what we're going to be working on this stream today. I'm in the middle of a UI rewrite for like how my like code, like my heads up display and all that stuff works, to make it more reactive. But I'll get into that a little bit after I finish covering what the game does. So, and then now you'll obviously probably notice like there's other stuff on the screen here. It's not just Atari's lunar lander, right? Like if it was just Atari's lunar lander, like that's this part, right? But then we also have like this terminal system down here. So what I thought would be really cool is to have a diegetic terminal included in the game. So like you're looking at uh, the game through like the way that I imagine this is like you are the astronaut that's sitting inside of the lander right now, and you're looking at the screens inside the lander in the cockpit. And so like this might be like your MFD where it's used for multiple different things, and we're gonna break the fourth wall a little bit, but like you can see yourself from third person, right? And then this would be the terminal that lets you kind of control different things in the lander. So this would be like integrated directly into the lander. And then over here we've got the like objectives and stuff like that. There's other things that will be in there as well. But for now, it's just the objectives specifically. One sec, I want to check something out really quick. Okay. Yeah, okay. So, so once you've landed, then, well, you can use the terminal at any point, really, but it's probably best to wait until you land. There are certain commands that you do need to use while you're flying, and I'll cover those in a second too. But like, for example, like I landed, right, and I can run, well, I can run help, right, help. And this, by the way, this is like a fully, like a full terminal. It's built the exact same way that like iTerm or like any other terminal would be built, in terms of like how it processes input, how it like does the columns and like, the lines and all that stuff, how even like the commands, right? The commands for the terminal, there's like actual like C++ like functions and files that are used for each command. So like the scan command has its own thing, you know? Corbin says, is the Singularity engine vibe coded, hand coded, or a mix? So for this project, since I wanted it to be entirely like done by me, no vibe coding has really been like involved at all. I use AI in terms of like an enhanced version of Google, I would say. Like instead of going on Stack Overflow and looking stuff up, or like reading through a bunch of docs, I'll like use AI as like my first pass of like, okay, what exists in this API or what exists in this library or something like that. But in terms of like the actual code, yeah, it's all handwritten artisan code with these babies right here, these fingertips. Um, wow, that's super impressive. Thank you. I appreciate it. Yeah, it's been a lot of work. It's the physics was a huge pain. The collisions were a huge pain, but and you'll see, I'm sure there's gonna be a bunch of like weirdness. I still have like collision clipping happening, depending on like certain collision angles and stuff like that that I have to iron out like before the actual game gets released and stuff like that. But it works, you know, so I'm pretty proud of it. Um, but yeah, anyway, what I was talking about was the terminal, and yeah, so the terminal has like different like C++ files for each command. I can show that in a little bit too if anybody's interested. But yeah, so like let's say I want to figure out like what a specific command does. So one thing I want to say though is like my expectation for the players of this game is like the players that are playing this game are curious, right? I want players to be curious, and so I'm not going to like handhold as much as I can. Obviously, like players need handholding sometimes. But like I might show players like, hey, like if you want to see what commands are available in the terminal, you can type help, and then you type help, and then okay, well these are the commands, right? And then I might show players like, oh, if you want to figure out how a specific command works, then you type like help, let's say, and then the command name. So let's say I want to figure out, okay, what does the opchk command do, right? So help opchk, and then you can see here, it's like, okay, opcheck, run a diagnostic check of the lander systems. So then it shows you the usage. In this case, op check is literally just you use it by just typing the command name, and then it performs a diagnostic check on the core landing systems, such as the landing legs, LiDAR, communications equipment, all that stuff. So I'll also run that real quick so you guys can see how that looks. So op check, and then right now there's really only like a handful of systems. So there's like hull integrity, which is 67%. So that's just analogous to what's up here. And then like different components. So like each landing leg has its own health, and they can break off and stuff like that. Um, so that you can see the health of each landing leg. And as we build out more systems, like we'll have like there's a whole LiDAR system in the game, and I haven't really added like a health thing to it yet, but it will. So like you'll be able to damage the LiDAR scanner, and it'll become less effective, you know. Corbin says, I love the Linux reference. These graphics remind me of some old DOS games. The idea of the terminal being explorable is amazing. Is it scriptable, like Turing complete? Not exactly. Thank you, by the way, the Linux reference. Yeah, I tried to like make it as much of a play on like Linux as possible. And I want it to kind of feel like you're kind of a programmer at the same time. Um, but you know, within reason, because like it's a lot of work to like make like a full-fledged terminal system. So and that kind of leads into the other question that you had: is it scriptable, like as in Turing complete? It's not right now. Like I expose these commands, and that's pretty much it. So like the commands themselves are written, you know, in C++, and then they get compiled into the game. And then the player is just able to use the commands for now. I've kind of toyed around with the idea of, yeah, maybe allowing at some point in the future, allowing users to like write little scripts to autonomously do things in the lander. And I'll show a few things that in a little bit that might apply to that. Like for example, like maybe if you're doing the same procedure over and over again, as you upgrade the lander, maybe I will allow you to have like lander memory or something like that, you know, as an upgrade path. And then once you unlock lander memory, boom, now the player is able to write some scripts or something like that, that automate like certain runs of commands, you know. But it's not currently Turing complete or anything like that. Mo the engineer says, have you considered allowing the player to use the terminal to autonomously land the lunar lander using noisy LiDAR, IMU, or other sensor? I've thought about it, and like I don't really think that that's the path that I want to go down. Just because I think maybe once I explain more of the core loop, you'll understand. But like half of the game is landing and then the other half is EVA. So if I make landing like automated, then you kind of have lost half of the loop. Now, like you mentioned, like noisy LiDAR or IMU, meaning like maybe the user still has to step in or something like that. And like maybe it's depending on like if they can pre-program it, I think that would be a really cool path to explore. I think the game's like just still too early right now to really think too deeply into that kind of system, but I wouldn't rule it out. Like I don't think it's a bad idea. I like I said, I've thought about it a little bit, but it's not something that I've committed to in the plans, at least for like the initial version of the game. Um, but yeah, okay, so I'm gonna keep running through things here. So I'm gonna run help again, and then so we got a bunch of other commands here. I'm not gonna bore you guys by walking through all of them. I'm sure we'll see them all during the stream. But there's also like I was trying to explain before. I want to like not hold the player's hand as much as possible. So like I said, within reason. So like once the player's been introduced to the terminal, I kind of expect players to dig around and kind of, you know, go hacker mode, you know, and try to find what they can. So like you could go into any terminal, and like each terminal might have different commands depending on what kind of computer it is or like what it is. So for example, like this here right now, this is your lander terminal. It's like directly integrated into your lander. So it has commands that are related to your lander, you know? But like something that's of note here is the log command, right? So um, you might say, okay, well, what does log do, right? So help log, and then it's like, all right, access mission logs, right? So then there's three like sub commands inside of log. So there's log list, there's log view, and log close. Um, So then, okay, like log list is going to show us a list of available logs. And now at this point, the player doesn't really know what these actually are. They're, these are just like what's a log, right? And as a gamer, I'm sure you can kind of guess, okay, like a log is probably going to be some sort of like story file or something like that, right? So I can do log list and then like view, and I'm controlling this with my keyboard right now. I plan. Oh, actually, I did. I was gonna say I plan on implementing mouse scroll, and, but I actually did. I prefer using keyboard for everything, so like I'm keyboard first, and then like afterwards, I'm like, yeah, I'll add mouse usage later. But yeah, so you can see like, all right, there's a few logs that are already in this terminal, right? And so like as the player plays through the game, they will like find different terminals across the world, and they'll be able to like access the logs. And when you access the logs of like a terminal that you've discovered, then they'll become available for you. Kind of like, in other games when you find like a piece of paper on the ground and it goes into your notes or something like that, and then you can access them from your like start menu or something like that. I want this game to feel as diegetic as possible, and like we have a terminal here, so I figure like all of that stuff can just live in here. So like I can do log view, let's say log view 7, right? And then that like lets me view this. So like this screen here is an MFD, the multifunction display. So I use the log command here, but then it actually displays the log up here, right? So uh, these log files are kind of like story snippets, right? Or like as you're, like if you've ever played Resident Evil or like Silent Hill, you go somewhere and you found like a note, and that note isn't necessarily like directly driving the story, but you can derive some information about like how things happen or how things came to be, um, from reading the logs, and kind of piece together more stuff than you normally would be able to do by just playing the story blindly. Um, so yeah, so that's kind of the one of like the main drivers of how the story works. So we'll just close that log. And then the one other really, really cool command that I think is useful is the scan command. And this is actually one of the only ones that like you will actually need to use while flying. And I did that kind of on purpose. I wanted to create like this feeling of urgency while you're falling, right? Because like on your first few loops, yeah, maybe you'll take some time to learn how to control the lander, because physics is kind of difficult. It's not as intuitive as people might think sometimes, like if you start spinning in space, there's no air resistance, so you're not really gonna stop spinning until you like apply the opposite rotation, things like that, and you have to keep yourself balanced. But like after a few runs and after a few like crashes and after a few landings, you're gonna get the hang of it, and it's not gonna really feel difficult. And I do want there to be like some like level of skill in how the like piloting in the game works. Um, so what the way that the game loop works is like the player is constantly respawning in the air and falling back towards the surface of the moon, and they need to find a landing spot and survive. Now like narratively there's a reason behind that, right? Like the game opens that there's this is more like just like the script for how I'm planning it, more so than like what's actually there right now. um but the plan is like the player, like the game opens to like a space station orbiting the moon, right? And there's some astronauts talking, blah blah blah, whatever, and there's a explosion all of a sudden, and like the whole space station like just gets torn apart, right? Luckily, your player, like the character that you're playing as, James Middlewood, he's an astronaut, and he is inside of the lander doing some maintenance on the actual lander that's docked to the space station, right? So as the space station explodes, he gets sent off hurtling towards the surface of the moon, and that's when you, the player, take control, and then now it's your job to actually go and land the thing, right? And but the thing is, like once you've landed, after a few minutes, your character blacks out, and you don't really know why. Like all of a sudden the screen goes black, you're blacked out, right? You wake back up and you're back in midair and you're falling again. Same thing as kind of before, like when when the space station exploded, right? So again, you have these pieces of space station debris falling down, like lunar regolith falling down, and you're navigating again, trying to land. And the that's kind of the core premise of the game loop is like you land, you have a few minutes on the surface to explore. There's an EVA phase where you, after you land, you can actually get out of the lander and explore the ground on foot, and interact with the world. And then boom, after those few minutes, you're back in the air again and you're landing again. Now the map is pretty big. It's like right now I'm like on a test map, so you can't really tell how big it is, or like it's not really like the final map. But I have the game split up right now conceptually into a few different acts, and the map of the first act right now is roughly 3,000 meters across. And so like the lander itself is like 10 meters across. So, it's a pretty decently sized map. So there's a lot of different areas for you to land, and there's a lot of different point of interests for you to explore and try to progress through the story. And then once you've like finished that act, you'll move on to a new area with a new map, and it's gonna be like equitable in size to the first one. I'm planning on having like roughly 3 or 4 acts that are like that. So a few different maps, each about 3,000 meters across in size, for the player to like explore through. So every time you respawn, but that's or like respawn. Every time you start a new loop, effectively, that's an opportunity for the player to land somewhere new, because realistically you only have so much fuel, right? So you can't like continuously fly around. Like I landed here, right? And that one landing like left me with like what, like 40% fuel, 35% fuel, for my main engine, and then like 60% thruster fuel. Like it's something, but it's not like I can maybe go to one other nearby area in this same loop. But that's kind of it. Like there's not really anywhere else I can go with that. So on the next loop, I would be able to go somewhere else. So the plan is players would need to kind of plan their gameplay across loops. So like maybe I need to do something in one POI, but then that triggers some other event at another POI, but that's too far away for me to do something with in this loop. So now I have to wait until another loop to go and trigger that. Or I have to remember to go and do something over there. Um, but yeah, so I'm gonna get back up into the air here because I want to show this other command. I'm actually gonna give myself infinite fuel for now, because it'll be really annoying to show this without infinite fuel. And so basically, let me give myself a little more throttle. I'm gonna get up nice and high. So like when you start off, you get each loop, you start off somewhere up in the air in a random like position above the map. And like I said, you're falling, right? So like when you're looking at this screen, you have absolutely no idea what map is below you, right? Like there's no way for you to tell what landmarks are anywhere, right? So there's a scan command you can use. So like scan auto, and then you specify the direction, so D, or let's say down, just to illustrate that. So this initiates a LiDAR scan, like a sweeping LiDAR scan that will show you what the ground looks like below you. Now, right now, this version of the scan is kind of like the super high resolution scan that you probably wouldn't have in the beginning of the game, like when you first start. You would start with a lower resolution scan, and like maybe as you upgrade the lander, it would get better resolution and resolve like more points. But yeah, so keep that in mind as I fly around. But now I can see what's below me, right? And I can kind of, there's like I can use my binoculars to kind of look around and try to get more of a view than what I do by default with the default camera. But like for all intents and purposes, I can really only see like maybe like 50 meters in each direction. So I kind of have to like traverse the terrain and uncover some of the map. Now, the idea is, what I want to include eventually too is a manual mapping system for players. Because the idea is like you're in this rinky-dink lander, right, from like the 70s, and like it was state of the art for its time, but it's it's not really meant for solo operation, right? Like even in the 70s, we had like 3 crew members on that lunar lander, right? But you're by yourself. You're a single player in this lander, right? So what do? Well, you have paper, and so maybe you can start drawing maps to chart the actual lunar terrain, right? So what I'd like to eventually add is like a drawing system, maybe with some like grid paper, and as players fly around, they can take snapshots. So like for example, I can stop the scan without actually exiting the lidar, right? So now even though I'm moving around, this scan is like static. So what I can do is if I had a system where I could open up a piece of grid paper, I could look at what this map is and I could draw, like maybe even trace what this LiDAR scan looks like onto a piece of paper. And eventually, as I do this enough and as I pass through the map enough, I can stitch together my own little map of the lunar surface that's below me for this act, right? And you know, I'm not masochistic. I don't want players to hate me, so I would put like a little blip, you know, on the like paper showing, hey, this is where you are relative to, you know, the stuff that you drew. But that way it gives players like a way of sort of mapping the surface before, without like having to always rely on the scanner. Corbin says, "Man, that's so cool." Thank you, Corbin. I appreciate that. Yeah, the lidar scanning, it was actually super tricky. Like if you pay attention while it's scanning, let me start another scan. It auto adjusts, like as you get closer, it has to adjust the terrain below you. Because if I always kept it a static size, since your lidar only has so much range, I think the lidar itself has like 800 meters of range or 1,000. I don't remember. I have to check the code. But like you would only ever be seeing a small slice of the like land below you, so it looked really weird. So if I like by allowing it to auto adjust the scale of what's below you, it's always fitting all of the points that have been scanned into this little window here. So you're always getting like a decent like size view and can actually see what's below you. But you can also scan in other directions. Like I can change the angle, right? I can just say right, you know, and then it'll start scanning to the right. If there was like a cliff over here or something like that, I'd be able to scan to the right. And that's actually what's happening, right? Like there is a cliff over there, and like I can use the scanner to kind of prepare myself so that I don't go and crash into the cliff that's on the right side there. But you can also see these little blips that are showing up down here, right? And the scanner will pick up and like kind of mark certain types of objects. So like anything blue is something that you can collect. And I think this would also eventually be kind of an upgrade for the scanner. Like by default, I don't know that I want to allow players to just have that. But right now, you know, it's in debug mode or like, you know, early development. So a lot of stuff is subject to change. Corbin says, does the game assume effectively unlimited electrical energy for onboard systems? I see that you have fuel, but what about all the computers? Kind of, yeah. So the actual, well, no, not the actual lander. The way that I'm thinking about this game and the lander is like, it's a mix of old tech and new tech. And honestly, this isn't even really a new tech kind of thing. But like, all right, like think about the government now, right? Like we repurposed some of the space shuttle solid rocket boosters and used it for Artemis, right? Like those are the same boosters. Or wait, no, is it? No, sorry, I don't know if I'm wrong about that. And it's not the boosters. I know for sure the RS-25, the actual engines, were repurposed from the space shuttle. So like we already see this, right? So I'm imagining this world exists. We exist in a world where like the old lunar landers from the 70s were repurposed and kind of augmented to be used for like different purposes beyond what they, yeah, not the boosters, it's the engines. You're right, yeah. I think it is the RS-25s, yeah. So we already live in a world where the tech gets repurposed, right? So the idea is like we have on, I think on the Voyager probe and some of the other probes that have sent out, they have RTGs, radio isotope thermoelectric generators, and these are basically just like mini I don't want to say this because like technically inaccurate, but it's basically like mini nuclear reactors, for lack of a better term. They work on isotope decay, but that's what provides these systems like the Voyager with these long-running electrical power, right? So I imagine that the lander itself has a RTG on it, and that will keep the actual electrical systems running, but not infinitely. And like I also have plans for a whole like electricity transfer system where like sometimes you need to land the lander somewhere. Like maybe you encounter an old research lab, right? And this research lab, the power is out, right? The doors aren't working. But you need to access something that's inside of there, right? So the lander, because it has an RTG, you can connect it to these doors and like disperse some of that power into the doors to power them, you know? So in that way, the lander kind of becomes a key. So in short, basically, I would say that the lander itself never really runs out of electricity for its core systems, but you could run out of electricity for like external applications, like if you wanted to open a door or something like that. That's going to be more of a managed resource that players have to think about. Corbin says the boosters are significantly modified versions of space shuttle SRBs. Yeah, that makes sense. That checks out to me. I knew there was something there, like there was a correlation, but I didn't want to like make a claim and then be wrong, you know, because who likes being wrong? Not me. Okay, so these little blips here, they're things that the player can collect. Like I said, I think this is probably going to be like a an upgrade at some point. But there are certain things that the scanner comes with right away. I'll show that on the next loop. I'll probably have to kill myself to do it, but I will show how that works. But effectively, like you use the scanner for two different reasons. You want to know what terrain is around you, but you also can use it for encountering uh, hazards or like projectiles. So like if something is flying towards you, well, why wouldn't you be able to use a LiDAR scanner to effectively like scan something, and then on the next scan wave, if it has moved significantly, like you'd be able to know like, okay, there's something that's moving fast and it's moving in this direction based off of the delta, you know? So that is a system that's in the game. As a matter of fact, let me go ahead and just show that. I'm gonna dive bomb here a little bit, and see if I can also show some of the, like one of the legs breaking off at the same time. There you go. Leg broke off. There you go. There's some of that like jank there with the physics that I was talking about. Um, and you restart. It's basically just like a little boot screen. I thought it was kind of cute. And the idea is like the lander's rebooting after you just destroyed it. There's like the story kind of ties everything together, but I don't want to give too much of it away. So yeah, we're pressing enter to go ahead with the thing, and you'll notice though, like the lander crashed and the right leg broke on the previous loop, and that like transfers over to this loop. So it's not like, you know, you die and then all is forgiven. You have to now live with the consequences of your actions. So actually, I wanted to show the scanner working with hazards. So here, now I'm scanning for hazards so that like if something's far away, because like sometimes they'll be moving fast, right? And I want to be able to dodge them. And it's kind of unfair if something's moving really fast and I have absolutely no way of preparing. Like this one right here, there's something right above me. I can't see it on screen yet, and like it might hit me, right? There's some UI weirdness. This is what we're gonna be fixing later. This is what I was talking about, that UI rewrite. But yeah. So that's how that works. And then once a thing no longer becomes a threat, it actually turns into like a yellow icon there, just so that you still know where it is, because it's useful to know where those things fall. Because when something crash lands, you can actually go to where it landed and then like potentially gather some scrap and resources and stuff like that. So like when I scan down now, right, like any blue dot that shows up, that was like a piece of debris that crashed into the surface and now has like some scrap there that like might have something in it, might have nothing. Right now, I have it set so that every single time it will have scrap, just, you know, for testing purposes. But like in the production release of the game, it'll be more random. And I'm sure you'll notice here, or maybe it's a little more subtle. It's noticeable when you're playing. It's maybe a little more subtle on the game, like when you're watching. But like if like I'm missing this leg, right? And as I'm boosting right now, like the shuttle itself, like it's turning on its own, and that's because the mass is imbalanced, right? Like I'm missing a leg here, so I have more mass on the left side than I do on the right. So now you have to manage that. So like it's number one, it's harder to land, right? Harder to land without taking damage because now you don't have this extra leg, which is going to absorb some of that like impact. But it's also harder to fly. But it's only harder to fly if the legs are extended. So like if I retract the legs, like now I'm no longer affected by that like mass imbalance. So it's more so just making it harder to land specifically, you know. There's a way to fix that. There's a crafting system in the game, and you'll be able to effectively like create new landing legs to replace the ones that have been broken. You take hull damage, and so like you'll be able to also repair the hull with what's called a hull patch kit. And all this stuff is done by collecting the scrap that's on the surface here. And there's different materials within that scrap, those scrap piles that you might wanna be able to pick up. Um, and then those different materials are used for the crafting system. And I'll show that right now. I'm gonna go ahead and land. There's another really cool system that I want to show, but I think I have to get some scrap in order to actually show it. So once you actually land, oh gosh, what's going on here? That was not supposed to happen. Let me just try restarting the game. I think something weird happened there that I don't like. Uh, while I do that, Corbin says, if you're the only dev, this is extremely impressive. Like all the places are here for a game for folks to get our Kerbal Space Program fixed plus roguelikes. This must have taken an insane amount of time. Like believe it or not, it took a while. Like don't get me wrong, it was a lot of work and it was a lot of me like no-lifing code. Um, so it did take a long time. I don't want to underplay that, but like the majority of what's in the actual like gameplay there was done in like the first 3 months, and that's including building the engine. So it happened faster than I thought, but like there's like the old adage that says like the last 20% of the work takes 80% of the time, the first 80% of the work takes 20% of the time. And I'm not claiming that I'm 80% of the way through the game development. It's like super rough. There's a lot of stuff that's missing here, but like a lot of like what you are seeing here was done in 3 months, and then after that it's been like 9 months, like 9 months of much slower progress, like performance improvements and like working on like certain subsystems and like particles and stuff like that. Admittedly, I have been working less on it, so like the first 3 months I must have worked like I would get off of work, off of my like regular like 9 to 5 writing code, and then I would probably spend another like 6 hours a day writing code for this game, you know. Um, and I did that for like three or 4 months or something like that. But now I've toned it down quite a bit. I like now I think I'll do like more like 2 hours a day. So it's still progress, but it's significantly slower progress. Okay, let me see if I can land this thing and I show you guys this other system. I'm gonna scan for hazards. So like typically this is how I imagine players playing the game. Obviously players will find their own way to play the game, but you're gonna scan for hazards. Oh, I'm gonna crash here. I do not have enough thrust. It's pretty hard to like talk and play at the same time. Um, I'm not focused enough. Let's try that again. I'm gonna scan again. Scan O2 up, and then we're gonna keep an eye out for hazards. I want to know where things are gonna fall so that I can, after we land, I can show you guys the other, like the other system that I have here in place. That's about to hit me. So there's like that little, like you can, you have the normal movement. I want the lander to feel relatively sluggish, so like you're not like super agile. This isn't like a roguelike, you're not dashing all over the place. I want it to feel tactile. Like you're controlling this heavy big thing, that wasn't really made to be agile. It was made to be light and steerable, well, which kind of doesn't sound like It doesn't sound like it's the opposite, right? But like it's not made to perform crazy evasions or anything like that. Anyway, I'm gonna stop scanning now. There's a few things that have fallen at this point. Oh god. I probably let me land. Let me land before I do something weird. Okay, so yeah, and then you have to also manage your landing leg deployment. Like, if the throttle is above a certain percentage, like above 75%, then the actual flames from the throttle will damage your landing legs. So you can't just constantly fly around with your legs and just like plop onto the ground. The legs will absorb more impact. Like if you land just on the actual like engine itself, the body itself, um, you have less grace than if you land on the legs. Like they'll absorb more impact. So you can have a harder landing on the legs. Now, the legs have their own like health, like component health. So like they'll take damage and stuff like that and you'll have to repair it, but at least you won't die, and waste like a loop or something like that. So, um, you have to manage the gear deploy state. I'm going to stop the scanner. And so like, let's try getting out again. There we go. We actually were able to hop out this time without the UI getting all weird. And this is all like hand animated, hand drawn. I'm not like the best artist, so a lot of this art took a while. But it's there. I think like I'm relatively happy with like how the astronaut looks and how the lander looks and stuff like that. And I'm sure you must have noticed, like, or maybe you didn't, but as you get out, you want to control a player, so it's gonna zoom in. So there's two different like level of details for the lander. There's like the all the way zoomed out view where it's like a couple of pixels, and then there's well, now I'm a player, like I'm an actual astronaut, so I need to provide a much higher resolution view of the lander. But yeah, so the player has an inventory. It's like a Tetris style inventory where you can like carry items, but you can only carry so many items. And you might like be able to find, like, you see this is the Mark 1 of the inventory, so you'll be able to upgrade it, but it's still not going to be anything crazy, And the least fleshed out portion of the game, I'd say, is the EVA. Eventually I want to have like oxygen management and stuff like that, where like the lander will have like infinite oxygen. You can go and like kind of replenish your oxygen there, but like once you go out onto an EVA, you only have like X amount of time worth of oxygen. And then the amount of stuff that you're carrying, or like rather the mass worth of stuff that you're carrying, will affect your oxygen consumption and stuff like that. So you have to manage that carefully. But anyway, so over here we have a debris pile, right? And this debris pile can have like random stuff in it. So like right now, it's got two pieces of alloy. These have one piece of alloy, and each piece of alloy weighs 2 kilograms, right? So we can take that. Again, the UI is pretty weird right now. Don't judge me on this. It looked a lot better like a month ago before I started doing this whole UI rewrite, but there's a lot of weirdness. Anyway, I'm gonna pick this stuff up, right? And now normally, like, if I have a bunch of different shapes worth of stuff, then I have to like actually move stuff around and try to fit all the stuff in my inventory, right? So like I might reorganize how I do stuff, right? But for now, I only found two things, so I'm able to just carry that. Now, like I said, you only have a limited amount of space in your inventory, and there might be multiple different things you need to craft, right? Like, again, a landing leg, or an improvised patch kit to fix the hull of the lander, or, maybe even like a health item for the astronaut, like if you took fall damage or something like that. I'm not really planning on having combat in the traditional sense. I don't want this to be like a side-scroller shooter kind of thing. I want it to be more of like a what the fuck happened, kind of thing. Like, I'm exploring this unknown world. But yeah, anyway, so the lander itself has its own inventory, right? So you get near the lander, you can see the lander's cargo hold, and you can move items from your inventory into the lander. Now, the thing that I want to like show off here, it's like I think it's really cool. It was a pretty fun system to implement. It's mass balance distribution. So where you put stuff into the lander's cargo hold affects the balance distribution of the actual lander, so it'll change how it flies. So for example, like I don't have a lot of weight worth of stuff here, but and it probably isn't enough to demonstrate how extreme it can get. But like if I take this alloy and I put it on the left side, it's showing like, okay, like your lander is skewed off to the side by some amount of units, right? Now if I add this in here, it's even more skewed now. And the lander will kind of like rotate to show how off balance you are, and you can probably just barely see it on stream because it's like we barely have any weight worth of stuff in here, but it takes into account exactly the positioning of it. So like something that's higher up will have more of an effect. So like remember this says 8.2 units here, right? And so now if I move this up higher, now it's 9.9. And the weight of this item didn't change, but it's like these units represent how off balance the thing is, you know? So like if I'm putting everything really high up and I have nothing below it, like I can get really skewed, you know? So I want to have all my heavier stuff lower down, closer to the center of gravity of the actual lander rather than higher up and throwing off the balance, you know? Um, but there's also like a little bit of emergent gameplay here because like, for example, like imagine I broke off my right landing leg, right? Well, and I don't have enough materials to craft a new one. Well, that means like if I'm going to land, my lander wants to turn counterclockwise, right? So what can I do? Well, if I take all these items and I put all my weight on the right side of the lander's cargo hold, that's going to offset the fact that I'm missing a landing leg, or at least it'll offset some amount depending on like how many units worth of like imbalance you have. And I think like the a missing landing leg is like 75 units of imbalance, so you would have to stack a lot of items on one side to make up for a landing leg because they're heavy, you know. These things weigh like thousands of pounds. So you would have to get smart with it. But remember, if the landing leg is retracted, then the landing legs the fact that the landing leg is missing does not have an effect on the balance distribution anymore. And so like you might be overbalanced when the legs are retracted versus when they're extended. So you have to think like, okay, do I care about I'm missing a leg. Do I care more about my landing configuration or my flight configuration? Like do I have a harder time landing or do I have a hard time flying, you know? And like if my landing configuration is what I'm worried about, maybe I'm okay with like having stuff more skewed to the right and being imbalanced while I'm landing, if that means that, or imbalanced while I'm flying, if that means that while I'm landing I'm more balanced because it's going to balance out the mass distribution, right? So that's that stuff. There's a crafting system in the game as well. Let me close my inventory. So again, a lot of, you know, programmer art. I just, you know, this an empty hill here, an empty gray hill, very boring looking. I've started kind of implementing some like some tiling just for like some visuals. It's very rough. There's very little actually in place. Ignore this giant yellow box. I'll probably explain that at some point later, but it's there for a good reason, I promise. And then over here, so the way that the crafting system works is like you start off and you have a certain level, like some level of knowledge, right? Because presumably you're an astronaut or you're an engineer or something like that, so you know how to do certain things, right? So you might know automatically how to craft a new landing leg, right? But like you don't necessarily know how to patch the hull, right? Or maybe you don't necessarily know how to create a, you know, a healing item because you're not a doctor, right? So what you might be able to do is find blueprints scattered across the world. So like this, like I already know how to build a landing leg, so I can see my blueprint manifest is what I call it. And it shows me like, okay, in order to create a landing leg, I need like alloys, and again, like the UI is being weird, but I need 2 alloys for the structural frame. I need 1 alloy for the foot pad assembly. I need 2 actuators for the deployment system, and I need 1 circuitry for the control harness, right? Cool. So now I can plan accordingly, and like as I collect stuff, I can always check in and just say, okay, cool, I know what I need. And because what I don't like in games is when you have a crafting system, but then like you can only see how to craft stuff at the crafting station, and it's like, all right, well, like I need to know what I need to collect, you know, and I don't want to have to keep making trips back and forth. And especially in a game like this where like your fuel is a resource, like it really would suck to have to go back to like a crafting station to then figure out what pieces you need, because then it's like, okay, I fucked up, I didn't pay attention to what I needed to craft, and now I have to go waste fuel to go figure out how to do it, you know? It's not a good feeling. So I wanted to make sure that there was like a way of accessing your blueprint manifest here, like just directly through your like your normal game UI, right? But notice, okay, we only have this one blueprint here. So we can, like, throughout the world, we'll find blueprints around, like, you know, like in random places. Like you might enter a building or something, you access a building with a key card that you found, and inside of that building there's a blueprint attached to the wall, you know, and you walk up to it and it's like, oh cool, like this blueprint will teach me how to make an improvised patch kit. So like I'm just gonna pick it up. There's no fancy animation for it yet, but now that I've picked it up and I go here, well, look at that, I have a blueprint for an improvised patch kit. And coincidentally, I actually have all the stuff that I need to make it, because I need some adhesive cartridges, I need some sealant for the adhesive cartridges, and I need one alloy for the perforated hexagonal panel. Cool. But like, you'll also notice that like my inventory is empty, but it's saying that I can craft it, right? So it takes into consideration what's in your lander inventory, just to make your life a little easier, because like, who cares if you don't physically have it on you? Like, you can craft it, you know? So I'll actually demonstrate that here. I'm going to try to hop over this, and go back to the lander and grab the materials that I have in there. And I'll go back and show that crafting system over there. Let me see actually what's in here. Can grab these two. Whatever. We don't really need them, but I'm a loot goblin, and I don't like letting digital loot go to waste. It's such a shame, you know. Okay, so we've got this alloy here. We've got some sealant. We grabbed it out the cargo hold, and we're gonna go. Honestly, it probably would have made sense, like, if as a player, if I know I'm gonna go craft, it probably makes sense for me to go land next to like the crafting area, and then like craft there, instead of like making this trek. Because again, remember, like, right now there's no oxygen management system, but like in the actual game, when it's released, you're gonna have only so much oxygen. So like, it's not worth going all the way over here to craft. It's probably worth, you know, using a little more fuel to get over here. But anyway, all the crafting happens at this fabricator. There's probably going to be multiple of these across the map. Maybe like 1 or 2, maybe 3, depending on how big the map is. I don't want it to be like super easy to get. Like, you shouldn't be able to just craft anything anywhere. I want it to be like, okay, I have to craft, so I have to like dedicate this loop to going to do some crafting, and maybe I can do some exploration in that area, but like, this loop will be used for crafting. And these loops, like, they don't last long. It's like 10 like minutes per loop or less, you know. And the loops, as you progress through the game, the loops get faster and faster. Like, you have less time between blacking out and spawning, so you have to have more and more stuff that you're doing in between. Or sorry, you have to be more and more efficient in between each loop. I don't know why I said that. Anyway, so now this is an example of another terminal that you would be able to access. So in this case, like, this terminal here, it's similar to the terminal that was in the lander, but you can see that there's a lot less commands here. There's not really much to do, right? This is another Linux shell. They're all, right now, they're all Linux shells, but this fabricator itself has its own terminal with its own commands, right? So really the only one that we care about in here right now is fab, but we don't know what it is, so maybe we want to do help fab, right? And it outputs a whole bunch of stuff. I'm going to scroll up. So fab is the primary interface to the onboard fabrication system, right? So this is basically the way that you would control the fabrication. Now again, weird UI weirdness here. This is like a little like caution note or something like that would appear on like a bulletin board. The UI, the text is being weird because of all the UI stuff that I've been working on that we're going to be spending some time fixing in a little bit. Anyway, so we've got fab list, fab info, fab select, fab begin, and fab abort. So then there's just some instructions here about how the actual fabrication procedure works. I'm not going to read through all of that because it's a bunch of text and that's not fun. But luckily, I've played this game before, believe it or not. And so I know how to do this, I think. Let's see. So I can do fab list, and I can see, okay, what are the things that I know how to fabricate, right? And this is directly tied to your blueprint manifest that I was showing earlier. Like, I know how to craft an improvised patch kit, and I know how to craft a landing leg, and it's because I've found those blueprints at some point, right? So then I can go ahead and I can do something like fab select, and I remember before it said that I had all the materials that I needed to craft the improvised patch kit. So let's go ahead and try that. So bear with me because this might not work. I haven't tested this since I started doing all of the the UI rewrite stuff, so we'll see. I hope this works, but if it doesn't, don't hate me. Um, Geez, that looks terrible. Okay. The inventory UI right now is overlapping with the blueprint UI. Um, so that's pretty ugly. But I can just take this and move it in there. That right there, the fact that that says 0 right now is telling me this is not gonna work. I'll try it anyway. I don't think it's gonna work. So I need an adhesive cartridge in here. So let's see. Does that fit fab begin? Okay, yeah, it says missing materials. It's because it didn't count it properly. There, like I said, I've been working on the UI, and the UI has been changed to be like more reactive. But like it's obviously not being very reactive right now if it's not counting the stuff that I put in there. It's like I'm literally in the middle of a rewrite. So a lot of stuff was broken, and I've just not fixed all of it yet. But anyway, what would happen at this point is I would have slotted the materials in from my inventory, and my inventory would not be overlaid on here. It would be over here on the side if it was being loaded correctly. Um, but I would slot all the materials in, and then I'd be able to do fab begin, and then I would get like a little loading bar. And then this fabricator, it's a 3D printer. It's kind of hard to see, but the print head would go ahead and move, and it would effectively print the item that I'm trying to craft, and then I would get that output item and I'd be able to put it back into my inventory when it's done. There's I plan on implementing like fabricator like mini games that control the quality of how the items get created. So like for example, maybe like one of the mini games is after you start the fabrication, you have to align the print head to like have a good like quality print. And like in order to align the print head, like there's like a laser scanner that's going up and down, and you have to press like space at the right time to like align it in that spot, and then maybe it goes left and right, and you have to press space to align it, and there's like a like dot on the screen or something like that. You're just trying to like create a cross directly on the dot to like align the print head, and depending on how well you align that print head, that would affect the quality of the print. And then like I imagine you would do like 2 or 3 of those types of mini games where like maybe one is aligning the print head, one is managing the laser temperature because this 3D printer prints by firing a laser into this liquid. So maybe like you have to manage the laser temperature by controlling some gauges or something like that. And then by the end of it, boom, you depending on how well you did on those 3 different mini games, you get a certain like quality of print or like of the part that you're trying to create. So like imagine like I'm crafting a landing leg, right? And like in order to get a landing leg with let's say 100% health, maybe I have to have like at least cumulatively 90% quality on my print, right? Or like on my alignment process. And if I go below that 90% threshold, then depending on like how badly I aligned or how poorly I did on that like uh, on that step, the landing leg might have less health to start with because like the landing legs, like they all have their own health, right? So maybe instead of like let's say you did like actually pretty poorly and you bombed all of the mini games for the alignment stuff, maybe you get like a landing leg with like 60% health instead of 100%. That's a pretty big penalty because you had to use materials to create it. And those materials you gather by playing through the loops and like landing in certain places. So it's costing you fuel and it's costing you time. So you wanna optimize for getting good prints and not just spamming through it because it's not worth it. Um, and so like and then there's other systems in place or that I plan to have in place too, like patching the hull for the lander. You probably saw it before, but like as the lander takes damage, you the lander's health bar goes down, right? Like it's a game. That's how it works. But you want to be able to repair the lander, and the lander doesn't get repaired between loops. Like the damage that you sustained in the previous loop is going to persist into this current loop, right? So one of the items you can craft is that patch kit, but you can also use scrap to repair the lander directly, right? And each scrap might give you 1% of a repair, but the improvised patch kit maybe it'll give you like like a 10% repair, you know. Um, and then on top of that, there's also in order to do certain actions, like for example, like if you want to attach a landing leg, right? Like your character is not strong enough to attach a like 1,500 pound leg to a lander, right? While it's on the ground, no less, right? Like think about changing the tires on your car, right? You lift up the car with like a jack, and then you can put the wheel, you can take the wheels on and off, but like you can't feasibly do that without a jack, you know. So that's what that yellow thing is over there. I'm gonna give myself infinite fuel again. That's what that yellow thing is over there, right? Like, I've been planning on building out what I'm calling a service bay. So the service bay effectively is like the place where you'll do all of the work on the lander, and it's a land. It has a landing pad which you have to land on, and once you've landed on the landing pad, then you can access the service bay via like a terminal or something like that, or some other interface to actually go and like attach, you know, the different parts or upgrade the lander. So like here you see like it says hoist lander. So you would hoist the lander after you validly landed on the landing pad. It would lift up the lander. You'd be able to attach whatever landing leg that you have there. Um, Kadawani says hi, new here. Hey Kadawani, welcome to the stream. Thanks for checking it out. Um, yeah, so um, you'd be able to land on the landing pad and like modify the lander. This is where you would do upgrades. This is where you would like attach the landing legs, like I was saying. But then also, like for example, if you have a patch kit, well, maybe you can use that patch kit. You can use it just like, you know, out in the field, and it'll give you like a 5 to 10% repair. But if you use a patch kit at a service bay specifically, it'll heal like 15 to 20%. So now it's like, okay, am I gonna like maybe I really want to repair out in the field because I'm doing really poorly and I can't. I have like 5% health, and if I have a bad impact, my lander's gonna blow up, you know. In that case, yeah, you know, you go ahead and apply the patch kit right there on the spot so that you don't just die, right? But if you want to play a little more strategically and you're like, I'm good at flying, maybe you save it until you get to a service bay and you apply it there. Kadawani says, wow, first one to pronounce it right. Thank you. I try. Cool game. What's it about? So it's you basically the gist of it is you're a astronaut. You were flying around the moon in a space station. Something happened. You don't know what happened as far as the player is concerned, and the space station explodes. Your character happened to be inside the lander at the time of the space station exploding because he was working on some systems of the lander, and he got like launched off towards the surface of the moon, and now you have to land, right? But like as you land, after you land, a few minutes go by and your character blacks out. Screen goes black, you black out, you wake back up and you're falling from the sky again and you need to land again. And basically the game is just figuring out, okay, what is going on? Why is it that every time I land, a few minutes pass by, my character passes out and I'm like landing again? And there's like a whole, like, you know, little narrative, like a story behind it, that I can't really go into too much because I don't want to spoil it, but that's the idea. It's super heavily inspired by Atari's Lunar Lander arcade game. This was originally just like a straight up clone of it, but since after I finished making it a clone, I wanted to take it further, so I just started adding a bunch of features and experiencing like way too much scope creep, and now we have this. There's a lot of systems in play here, but it's been a really fun thing to build out. Um, but yeah, so okay, that's the service bay, and that's how that works. So this is kind of what, like everything that we've got in the game. Like anybody who's been watching, uh, I've been kind of covering all the systems and showing what we've got. If anybody has any other questions, let me know. If there's any particular system you want to know more about, I'm really happy to explain it. But yeah, I think that's what I've got for the explanation for the game right now. That's the state of the game. Like I said, there's a lot left to continue working on. There's a lot to fix. There's I don't have a lot of systems in place transparently. Like, you know, the narrative, like there's no narrative system, no dialogue system, no quest system in place yet. But these things will all obviously exist. It's just, you know, super early in development. Um, but yeah, so with that, I think it's a good time to get started on some actual code. So I'm gonna go ahead and kill the game, and we'll go ahead and start taking a look at the code here. So there was one thing I noticed. Well, there's a lot of things that I noticed that were wrong. But we have to start somewhere. So I'm gonna launch the game again one more time. Actually, I'm gonna show you guys what I want to address really quick. Because like I said, there's a bunch of bugs. I want to start with something. So okay, right here we have the altitude at which the lander is flying, right? And this is just based off of some raycasts straight down, whatever. It's not too important how that's calculated. But point is, this is showing where like the altitude that you're at. But this arrow is supposed to be over here to the left. Now, like I said, I've been working on a rewrite of the UI because originally the way that the UI worked was or it still kind of works like this, and I'll draw a little diagram of it. But it's an immediate mode GUI, meaning like it's instantly on every frame, it's recalculating the entire UI, which is like super not performant. It's like really bad. But I kind of did it like that on purpose to start with because I just wanted to get something on the screen. I wanted to like have some visuals to interact with so I could like prototype the game out, you know? And like this, the game is built with a custom engine. I don't like for those of you who haven't, you know, been here for the whole stream. So like the whole thing's written from scratch. And so like a lot of my approach has been, let me get something on the screen, let me get something working, and I can optimize it when the time has come. And well, for the UI system, the time has more than come. There's a lot of there's a lot of performance improvements to be gained by changing how it works. So the first thing I want to tackle is the fact that this is like super off to the right. It should be like I'll fly up again so you can see a little bit better once again. This arrow should be on the left side of this ticker, but it's not. So I'm going to show a little diagram of how the UI works now, and then how I have changed it. Before I do that, I'm going to go and catch up on some chat because I couldn't see chat while I was in that. So Katawani says, I love the terminal look of it. Thank you. Yeah, I've been very intentionally trying to make the game very diegetic. I want it to feel like an old school, like you are flying like you're piloting a ship, you know, and you're in the weeds, and like you have access to the raw system, you know what I mean? So it's yeah. Then unknown GSJDY says, question, how did you make your custom engine? So the entire engine is built in C++. It's a lot of code. Let me see, like well, a lot relative to the size of the project. Let me clock source, I think, shows me how many lines of code are in this actual project here, just in my source, because I don't want to count anything outside of source. But it's even worse than I thought. It's 27,000 lines of code. But it's all C++. It's basically, it started off with just SDL3, and SDL3 is a window manager and like a graphics rendering library that's in C++. And eventually I got to the point where SDL3 wasn't enough because I needed to handle like I wanted to have shaders and stuff like that in the game, and SDL doesn't really let you do that. So then I ported pretty much my entire renderer over to OpenGL. So I can show that too as well. Let me see. I have a render pipeline. I tried to abstract it so that like if I ever want to switch to something else, like let's say Vulkan down the line, I probably won't, but or if I want to add support to it, because my plan is eventually I want to make the engine for the game open source. So like for now, the engine is just part of this actual project, but I want to open source it on GitHub at some point once I'm done with the game, so that, you know, I doubt anybody's actually going to use it to work on the game, but I feel like it's, you know, cool nonetheless. It's like an actual engine that was worked on alongside a game, you know. So it's like custom purpose built for the game, but I've been trying to make it generic enough that you can actually use it and like just hook into it. So yeah, we got like the render pipeline here. It handles all the rendering and stuff like that. Um, but yeah. And then Corbin says, I'm half paying attention while working on my own game, alt tab, but I have to say I'm really excited about this game. I want to buy it. Have a website yet? I don't have a website yet. Honestly, I've been a little hesitant to really share anything about it. Not because I think it's like my idea is going to get stolen or anything like that. You know, like ideas are super cheap and it's the execution that matters. What I'm more worried about is I don't want to like show this on like Steam or something like that and then like people be underwhelmed, because like as a developer, you know how much work goes into the games, right? Like we know the work that we're putting in, and you can look at another dev's work and you're like, wow, that like I know what it took to make that, right? But like as a gamer, like they don't know that. And I don't want to like put something up there with programmer art and then have someone take a look at it and be like, this looks like shit, and like not come back to it when like maybe they would have been someone who would have played the game, you know, if I had just like waited a little longer and finished building out a vertical slice first and then made a Steam page and then had them come across it that way. So for now, I've just been like, I just started a YouTube channel not too long ago, like literally like last week. I've started posting devlogs, and I figured, you know, let me stream on YouTube and Twitch at the same time. So it's, you know, this is how I'm kind of like premiering the game, I guess I would say, like more to other developers. And then eventually, once I have a polished like vertical slice, I'll share more with other people, like more of like the actual target audience, I guess is what you would say. Um, Katawani says, "Nice, I use NeoVim too." Yeah, NeoVim's pretty awesome, right? Like, it's super powerful. I used to use Emacs super early in my career, and I loved that too. And I might try it again one more time eventually. But like, I switched back to like Sublime for a while, and then I was using Atom for a few years. I was never really into like VS Code or anything like that. I'm not like a huge fan of IDEs. I want my stuff to be bare bones. I don't like all the extra bells and whistles that I don't use to be slowing my stuff down. So I like to have just like, okay, these are the actual things that I care about. And NeoVim lets me do that. NeoVim lets me have only the things that I want and nothing else. No, none of that other bloat. And also it's like super fast, and like all the motions and stuff like that are pretty great. Um, so yeah, it's awesome. Anybody who has not tried it, it's worth it 100%. Like if you give it a week or like 2 weeks, like an honest try, like you try to use it as your main editor for like 2 weeks, you will fall in love with it. I guarantee it. I yeah, quote me on that. Do it. Come back to me and let me know if you hated it, because then I'll probably feel kind of bad. But it's a learning experience, so it's worth it. Then unknown GSDJY. GSJDY. I hope I'm saying your name correctly. I'm studying computer science and I am learning C++. I'm not very good at it though. Any advice? Um, Honestly, my advice would probably be spend as much time coding as you can. Like it very much is a repetition game. Like I like put the time in, you know. Um, if you don't write code, you're not gonna flex that muscle. It's like going to the gym, right? If you want to get buff, you want to tone your muscles, you want to actually look good, you got to go to the gym, right? There's just no other way to do it. And your brain is a muscle, and your brain is a muscle that writes code. And if you don't train that muscle, it's not going to be very good at writing code or thinking for that matter. Um, so write a lot of code. Like anything that you can think of as like a side project, um, just build it, honestly. Uh, Spend more time than you think you need to spend writing code, and it'll pay dividends. Early in my career, I spent like very, very many hours outside of work writing code, and um, I think like I think I'm a pretty good developer. I don't want to toot my own horn, but I think I write pretty decent code, and I think I owe a lot of that to how much time I spent writing code in my formative years. Corbin says, I'm a cloud developer by trade. I host a beefy server in a data center with 24/7 uptime. So if you need any metal for CI/CD or a website, I would host for you for free without hesitation. Wow, dude, thank you. That's so kind of you. You know, I will hit you up if I need it, man. That's super kind. I appreciate that. That's very nice of you. Kadwani says, yeah, building bad software is how you learn how to build better software. Exactly. Write as much bad software as you can when it doesn't matter, so that when it does matter, you could go and make the good software. Um, yeah, there you go. And then Corbin says, advice for C++, in my opinion, as a non-expert, try to use modern constructs as much as possible. Old C++ is full of foot guns, but modern C++ is nice. Like, look, Alex is using standard unordered map. I'll be honest, I am also pretty new to C++. I like my entire career has been web dev, like 10 years of like pretty much entirely web dev. Like I'm a full stack senior engineer. But like I've worked mostly in like Ruby on Rails. I've done JavaScript in the past, or I do JavaScript now, not just in the past, like with Express and stuff like that, like React. I do a lot of that kind of stuff. But in my personal time is when I do a lot of exploration. And C++, I started learning, I guess 2 years now, 2 years ago now. I wanted to learn C++, but I also like I find that I learn best by working on a project. So like I didn't go and like read a giant C++ textbook and then try to like you know write it. I was like, okay, I know how to code. I've worked with other languages, so I was just like, I'm gonna build a programming language with C++. So then I started working on this language called Theta, which was really cool. Check it out on my GitHub if you want. It's all open source, but basically it was like a WebAssembly programming language where like you would write code, it compiles into WebAssembly, and then that WebAssembly can run in any like virtual machine or in the web or whatever. And yeah, it's like a functional programming language, a statically typed functional programming language. But then I moved on from that. I got enough of that done where I was like, okay, I'm happy with it, but like I didn't want to continue investing time into it because I got kind of bored of it. So then I moved on to this project. So now I've been working on this for like a year. So that's where those 2 years of C++ came from. And then unknown GSJDY. Also, the last part of my name is random letters. Okay, so I'll just there you go. I'll save the effort. I'll just call you unknown. Well, okay, cool. So, we were talking about the UI system in the game. So I'm gonna just diagram this out for you guys a little bit. Let me switch over to this screen. And so here, imagine like I'm sure most people are familiar with like HTML, right? Now in HTML you have like some tags. Let's say you have a div in there. I'll zoom in so you guys can see a little bit better. You got a div in there, and then inside that div, hi, what is this color scheme and font? 4V says, hi 4V. This color scheme, this is Dracula, my favorite color scheme. It's beautiful. And the font, I have to check. Let me see. I'm gonna check my iTerm settings. I think it's some monospace font. Let me see my profile, text. It's called Source Code Pro Nerd Font Mono. I'll throw that in the chat actually. Actually, is this even gonna go where I want? I'll type it out on the screen for you. I'll put it in a p tag here. It's called Source Code Pro Nerd Font. I can't type Nerd Font Mono. Yeah, it's a pretty decent font. Okay, so like I was saying, most people are probably familiar with HTML, right? And like maybe some people are familiar with the document object model, the DOM, the way that the browser works. Effectively, like this HTML gets transformed into some kind of structure inside the browser, and that's what is actually used to draw the page onto the screen, right? So and this is going to be kind of like an abridged version of how this all works, but like imagine the entire DOM as a tree, right? And it is structured as a tree. And the tree has a root, right? We've got a root, and then that root has some children, right? Now in this case, we just have the div, and that div has a p tag, right? And like bear with me here. So we've got root. Root owns the div owns the p tag, right? I'm going to label these as well so people know what I'm saying here. So div, Jesus, that looks terrible. Can I not make this look that bad? I think I'm just going to overlay the text so it's legible. So the div, right? And then we've got the p tag here, right? P tag. Okay. And then I'll just label this as well. Probably don't need to, but better to be clear than not. So okay, we've got the root of the DOM here, right? Now, this tree isn't very like tree-like right now. We've only got this is effectively a linked list. Like it's just directly following a chain, right? But now imagine we had something a little more interesting. Maybe we have a p tag in here. We've got a span, and inside of that span, we have, I don't know, maybe another p tag just to keep it simple, right? Okay. So now how does this look in our tree example, right? So the root, once again, has that div as a child, right? And then that div now, instead of just having one child, it's got multiple children. It's got the p tag in there, and then it's also got another child where the span lives, right? So we've got a span in here. Okay, cool. Now this span, and like the tree can, each node in the tree can have as many children as we need, right? It's not like it's a binary tree or anything like that. It can have as many children as we need to have in there, right? So the span also just has one child in here, and that's the p tag, right? That's this p tag here, which has hello in it. So I'll also throw that onto here, p tag, right? Okay. So now we've got all the stuff labeled, right? Okay, so this is the HTML, and then this is what it gets actually transformed into under the hood somewhere, right, by the browser. Now, the browser, why do we do this? Like, what's the point, right? The browser needs some way of iterating through the HTML or through the elements in the HTML and then drawing them onto the screen, right? And I know this is kind of like, okay, why are we talking about the browser? Like, you are not working on a browser, we're working on a game UI, but like it kind of it ties in, you know. What does span and div do? Unknown says. Those are like HTML elements. Div is basically a block element where it's kind of like a box on the screen. It handles like some margining and stuff like that. And then span is effectively the same as a div. It also is just like a container in the UI, but it doesn't like automatically have any margin. And usually it has like a CSS rule where it's like inline blocks, so things can be next to each other instead of it pushing stuff down. But that's not super important to what this actual example is. It's more of just like I'm just using HTML here because it's familiar for a lot of people. But these could be any kind of like XML or really any tree-like UI model, right? So we've got this tree-like structure here, right? And the browser wants something that it can iterate through, right? Because what we could do is like if I want to draw the screen, I can go from the root and I can traverse each child, right? So I can say, okay, from the root, what children do I have? Well, I only have one child. I can follow this child right here. I can go boop. Oh, geez, that's a huge stroke. Anyway, I can go here. That looks so funny. I can go from the root to the div, right, and traverse like following this path, right? Okay. Now the div maybe has certain rules in the rendering engine for the browser to determine how it's going to get drawn to the screen, right? Maybe let's say, just as a stupid example, let's say every time the browser sees an element called a div, it's going to draw a red box to the screen, right? So, well, here, I'll just illustrate that, right? Like, okay, let's draw a red box to the screen with no border, no border. Thank you. Okay, so boom, we found a we've got a div. We drew a red box to the screen because according to the rendering rules for the browser, anytime I see a div, I'm going to draw a red box to the screen. Now, we did the job of rendering the div, and now we can go ahead and traverse its children. Okay, well, what's the first child? We're going to go from left to right, and we're going to take a look. All right, the child of this div here, here, that's the p tag, right? Okay, and now let's say, well, this is a pretty reasonable rule, right? Every time we discover a p tag, we actually just render the text that we see on the screen. The text that's inside the p tag, we're going to render it into the page. Okay, so in this case, we came across this p tag, and this p tag here is related to this text here, right? Okay, so what I'm going to do then is I'm following the rules of the browser. I'm right here right now. So the browser's rendering rules say, okay, I'm going to draw the word source code pro whatever dot dot dot. Why not Troy showing us an actual browser email help get your idea across better? I don't think that I can really show this in the browser. I mean, I can show, there's not a good view here, to be honest, to show that. I can show you the HTML in the browser. But like, this is the HTML, right? And can you see this? Yeah, you can see this. You can see like all the elements inside of there, and then the div gets rendered inwards, and like we traverse inner as we go. But like what I'm kind of trying to get across is like each element has its own rules about how it's going to get drawn. Like for example, this logo here has a certain rule where it says like it's going to get a margin from the bottom of 38 pixels. So like if you look here, I'm highlighting it, this orange section, I'm like where my mouse is going right now, that orange section, that's the margin, right? Or like the padding on the top up there, right? Those are the rules of that specific element, right? So anyway, the whenever we hit the text nodes, the rules are we're going to just output the text onto the screen wherever that text gets, wherever we are in the tree, right? Okay, so we outputted source code pro, and then now, okay, we went as deep down this part of the tree as we could. So now instead we're going to go this way, right? Because that's the next step, right? So we went from here, we're going to traverse back up, and then we're going to go to the span. Now span, let's imagine that the span has a rule that every time we come across a span, we're going to draw a blue square instead, right? Stupid example. This is not necessarily how it works in the browser, but it works for the explanation here at least, right? Okay. So boom, now we have a square drawn in here, and now we're done with the rendering of the span, right? And we go on to its child. Okay, it has a child, and that child is a p tag. And what happens when we encounter a p tag? Well, we're gonna output the text to the screen, right? So boom, hello, and it's gonna be inside of that span, so that gets rendered inside of there. So now, like in a really naive like UI implementation, we would effectively just be going through the tree and then drawing that element into the screen based off of that element's rules. And in the browser, those elements rules are called CSS, right? The cascading style sheets. And that just determines like, okay, this element's going to be blue, or this element's going to be purple, or this element's going to have red text, or this element's going to have a margin left of 10 pixels or whatever, right? So those rules get applied depending on the element's class. Unknown says, so each element is unique on its own. Yeah, kind of. Like the element types, like a div will always follow the rules of a div, right? Or a span will always follow the rules of a span, or a p tag will always follow the rules of a p tag. But you can modify those rules, right, with CSS. As an example, within the browser, right, you would specify the CSS, and then the rules will be modified depending on what you specify in the CSS class for that specific element. So basically, this we just did like a considerable amount of work, right? Like we started here, and then we had to go down into this node, and then from this node we had to go here, and then from that node we had to go here, and then from that node we had to go here, right? And anytime I want to draw this UI to the screen based off of this HTML, I have to go and traverse this whole tree and redraw it, right? So it's a lot of work, but it's necessary work because these things might change, right? Like imagine I deleted this span out of the HTML, maybe using some JavaScript or something like that, right? Well, then now this whole thing should be gone, and now this hello should no longer be visible, right? It should be gone. So I need to traverse the tree to draw whatever's on there. Now, there's like some optimizations that you can do, so you might not strictly need to do that every single time, but for the most part, like, yeah, that's kind of, that's how you render stuff, right? So the way that my current UI code works is it literally will take, it'll go through the tree, and I'm not using HTML and CSS. I'm using like a custom thing, which I'll show in a second here. But it will literally go through every node in the tree, and then it's going to go and output that. It's going to draw that node depending on the rules of the style rules that have been defined by that node. You know, now there's a little bit of complexity there, because if these rules never change, then this is really fast to do. Sorry, my nose is really itchy for some reason. If the rules never change, then this is really fast to do, because I know, okay, every time I see a div, I'm just going to like draw a red square, and every time I see a span, I'm going to draw a blue square, and it doesn't matter because it's always done in the same order, and blah, 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 blah. And I can pretty much cache it to some extent, at least. And so like if it's impossible to change the width of a div, for example, in whatever UI engine, or it's impossible to change the text color, then it's super easy. You process it one time, done, right? Or like even so, like maybe if you're adding elements or whatever, you just continuously run through the tree over and over again, and render it over and over again, and that costs some amount of performance, but it's nothing crazy. The trouble comes in where, now what if I say I want to have something be a percentage of something else? Like what if I say I want this span, no matter what, I want this span to always be 50% of the box that it's inside of. So this span right now is inside of this div. So now the width of this span relies on the width of this div, right? Okay. Well, that's actually not so bad because I already know the width of this div. So like anytime I need to draw this span, I need to just look at the width of its parent and then recalculate. Okay, fine. But now what if the parent also depends on something else? Like what if the width of this div depends on the height of the root, right? Well, now I have another thing that needs to be recalculated. And like, as you make your system more expressive and more things can change, you start to have more and more places where you can have weird like performance things, right? So like if I'm recalculating the width of each element every single time because on every frame the width could have changed, well, that's a lot of like recalculation I'm doing. And honestly, most of the time it wouldn't change, right? Like from one frame to the next, the width of the element is probably the same on the majority of frames. You know what I mean? So all of those extra recomputations for that width gets wasted. And but that eats into your frame budget. You are using frames and you're using time to actually go and calculate those widths. Unknown says, how does JavaScript come in? You mentioned it earlier. JavaScript, in my game, I don't use JavaScript, but like in the browser, the JavaScript is, you can use JavaScript to control the DOM. So like you can add elements to the DOM or remove them. You can use JavaScript to make API calls. It's a bunch of different things. It's like it's a whole language of its own. But the JavaScript is kind of what like makes the HTML alive, so to speak. It's what makes it dynamic for the most part. There you can do some amount of dynamicness without it, but like anything that is really dynamic and like actually fancy, you'll end up using JavaScript for it. But yeah, anyway, so like constantly recalculating the width, or like any property for that matter, like the width, the height, the font size, the whether the text is bold or not, and like there's a lot of different style rules that you might want to be able to support in order to be able to draw a UI, right? And now if each of these style rules can depend on other things or might need to be calculated or might need to change, then the naive way to do it is say, okay, I'm just going to recalculate everything every single frame, and if I recalculate and I do some work that is extra work and it didn't need to happen, I'm okay with that, and I can take the performance hit of it because maybe my application is simple enough, right? And that typically that's called like immediate mode, an immediate mode graphical user interface, where we're just like continuously re-rendering, or like maybe not always re-rendering it, but like we're immediately rendering any changes. And that, at least for a game, it can work if your UI is really simple. But remember, we want good frame rates, right? We want players to have a good experience, and like so we want to have a high frame rate, or as high as reasonably possible, right? Now, if our UI is using a lot of frames because it's doing a bunch of recalculations that it doesn't need to do, well, then we're wasting computations that could have been used for something fancy, right? For more particles, for like a really cool lighting effect, for like, more entities, better pathfinding, all this other stuff that we could be doing that instead we're wasting the computation for by just recalculating stuff that we already know, or like that we could already know, right? So, well, what's the solution, right? Well, instead of me constantly like on every single step recalculating everything, what we could do is we can just say, hey, I can track the things that each node relies on. Excuse me. I can track the things that each node relies on, and basically use that to figure out when things need to be recalculated. So for example, if this span, if its style rules never, they're not dynamic, right? Like let's say the span always is set to be 5 pixels in width, and it never changes, then I know that the width of that span doesn't rely on anything, right? And if the width of that span doesn't rely on anything, I know that once I've calculated that width one time, I never need to recalculate it again because it won't change, right? And then like same thing with like any of the other style properties, right? Like height, font size, font family, any of those things. If they're not dynamic, then I know I don't need to recalculate them. But like, how do we know when something is dynamic, right? Well, we can use introspection, or like we can either use actual introspection or we can kind of fake it. In C++, there's not really a good way to do introspection, so we can't actually do it, but we can kind of fake it by tracking when things get accessed. So like imagine if anytime I'm inside of this span, when I'm calculating the width of this span, if I take all the variables that are being used in the calculation of that span and I track which ones were used, then I know, okay, let's say the span relies on the width of its parent, right? If I track that the span relies on the width of its parent, then if the width of this ever changes, I know that this span, and by consequence, anything below it needs to get recalculated and re-rendered, right? But like if the span doesn't rely on anything, right? Then we have like a hard cutoff here, right? Like if the span relies on nothing for its style rules, or like for the text that it's displaying or whatever, it doesn't rely on anything, then I know that anytime I go to the span, I can just render it with the sizes that I already know about. I already know its width, I already know its height. I don't need to do any extra work there. I can just render it, right? And I can skip a whole bunch of computation because anything that's in this tree now does not need to be recalculated. Now you can imagine as we get a more complicated UI, like this UI is super simple. This UI is not even like enough to do a single button, right? So as you start like increasing how much UI you have and the surface area of it, it's going to get more and more complicated, and you're going to be doing more and more computations. So if we can cut off computations here that we don't need to redo, we're going to save a bunch of, we're going to have much better performance. So that's effectively what what I've been doing for like the past month is I changed how my UI system works so that instead of always recalculating all the properties, all the rules of each element, instead I track which properties or which other things it accesses and use that to basically like reactify it, like only recalculate those properties when the thing that it relies on has changed. Um, So yeah, but because of that, I mentioned earlier in the stream, I'm in the middle of moving everything over. So a lot of the UI is broken right now because there's certain things that like, okay, like maybe the X position of uh, one of the arrows that's on the screen, maybe that X position relies on the width of something, right? And if I haven't updated that X position, or the width to be, I call them signals. I'll show the code for it in a second. If I haven't updated the width signal on the UI element property to be reactive or to be a signal, then the X position, which relies on the width, will not get updated, so it won't get re-rendered in the correct position. So that's how we end up with that weird thing the where the like certain buttons are in the wrong place or like the arrows are in the wrong spot. So here, I'm gonna switch over to the code view here, and we can kind of take a look at what everything looks like. So I've got the main class here that we want to take a look at is called UI element. So in the way that I was describing the nodes in that tree in the previous screen, that's effectively what a UI element is. It's just one node in that screen, right? It's one node in that tree. And every UI element is homogeneous in terms of like there's no special UI elements that have special roles. They all kind of they're all just containers for style rules and for their children. So a UI element might have a bunch of children. It'll have one parent. And what we can do is we can start with the root UI element that gets added to the game, and then in order to actually draw the entire like UI for the game, we just have to traverse down the tree and draw each UI element individually, right? Um, so yeah, so like you can see there's like each UI element will have like a width, it'll have a height, it has some helper methods like top, inner top, bottom, whatever. These are just like utility functions for other places when we actually want to go and like if I rely on other elements, width or height or whatever, just to make life a little easier, right? And then they also have this UI style property, and the UI style, I'll show what that looks like. It kind of looks like a lot, to be honest, but the UI style is basically, it's like my version of CSS if you've ever worked with HTML and CSS, uh, except it's not exactly the same thing. So like you can specify the X and Y position of the element, and this X and Y position by default is relative to the parent element. So like if the parent element is 400 pixels from the left of the screen, and then this child element has a X position of 2, then the child element will get rendered 402 pixels from the left of the screen, right? So that's the default. You can change that. There's a, where was that? It's the position property, which allows you to specify, okay, I actually don't want this to be relative to the parent. I want it to be relative absolutely to the screen, right? So a lot of this stuff is like very, very similar to how HTML and CSS works. So like if you would, the UI element itself is effectively like the HTML node, and then the UI style is effectively the CSS for each class, or for each element node, right? But the UI style is like the declarative, or originally the UI style, the way that I built it, because I didn't need this to be reactive, the UI style was the rules for how the active rules for how the UI element will calculate certain properties. So I'll show it a little bit more in a bit, but like the UI style struct would, you could specify the height, right? And then the height could be just like an actual number, or it could be a function which will return a number, right? And in that way, like you can, inside of that function, you can actually calculate, hey, I want the height to be based off of XYZ, whatever, and then use that to actually return what the height of that element should be. But because of that, this height isn't actually stored anywhere necessarily. It might get stored on the UI element, and like certain properties like the X, Y, width, and height will get stored on the actual UI element. But other properties like the border thickness or the font size or whatever, these don't actually get stored. So like if there's a function that's being used to calculate the font size, every time I need to get the font size, I'm gonna have to run that function. Again, super inefficient, right? We don't want to do it this way, but it was good enough to start with. Okay, So here, I'll show an example of what the actual UI style stuff looks like. So I have like effectively these style sheets that I have. So Lander style sheet CPP. So for example, like this effectively is like a UI style for one of the elements in the game. So there's a main game panel container element, right? And this struct here kind of highlights what the style rules are for how that element gets rendered. So in this case, its X position is always 4 pixels. So it's going to be 4 pixels from the left, and its Y position is actually calculated. So you see here, it's a function, right? So it takes in this lambda. And in this case, the Y position is based off of the screen height minus the element height minus 4, right? So, well, what does that mean? So to calculate the Y, I need to know what the element height is. And in this case, the element height is 70% of something, right? And when we have percentages, it's percent of the parent. So whatever the parent of main game panel container is, the height of this element will be 70% of that, right? Okay, so in that case, in order to calculate the Y, we need to first calculate the element's height, which is going to be 70% of its parent. Then we have to also find the screen height of the current. Well, it's the window height. These need to be renamed, but it's called screen height right now in the game. So we can use the engine to get the screen height. We subtract the element height, and we subtract 4. And then that gives us, okay, that's the Y position of the main game panel container, right? And then width, height, and padding, whatever, right? And then these elements get nested, and based off of how you nest them and based off the colors that you sent and all that stuff, that's how we actually end up drawing the UI to the screen. So what I've started working on is this pulse UI reactivity thing, I'm calling it. Effectively, like each property could be what's called a signal. So let me see if I can find it. Where is X? Okay. So right here, you'll notice that it's different, right? Like in this case right here, the X of the UI element is it's a float, right? But it's wrapped in this pulse computed thing, right? And a computed is basically you can think of it as a signal. And maybe I'll go into the plumbing of it someday. I probably won't go into it on stream because it's a little bit complex. But effectively what happens is it's a wrapper type over whatever type you have in here. So if you've got a float, pulse computed will wrap that float and it'll store the float internally. But then if something accesses this value, it will keep track of what accessed it. And if this value changes, like let's say X right now it's 10, and later X becomes 15, it knows, okay, on the previous frame, these are all the things that accessed me. And so I'm going to let them know, hey, I changed, X changed. And so those things that accessed X now know, oh, I depend on X and X changed. So I need to go and recalculate my value, right? That's effectively what's happening. And so like that's what a signal is, right? In this, I'll show you what that looks like. That's what a signal is in Singularity. It's like a engine construct, right? And you can kind of see it stores the value inside of itself, and then whenever you call get, there's like a pulse context, which is just for that one frame, and whenever something accesses it, it registers that as a dependency. Now this is all for the UI, so we only really care about what other UI element node accessed this during like the rendering phase of the UI, right? So we always have some node which is like the current node. So when we call context register dependency, we pass in node, and so we know, okay, what's the current computation that's being run, and we effectively register this signal as a dependency for that node. So later we know where to send that notification to about like, hey, this value changed, you know. Now there's also certain things that should be signals, but they should also be computed, right? Like let's say I have, like, honestly, the x, right? The x position on any element, right? It's a signal in that, like, maybe some other node might want to rely on the x position of this UI node to calculate its own x position. So like if this x position changes, that one should, that the child node should be notified, like, hey, your x position, my x position changed, so you need to recalculate your x position, right? But if I want to be able to recalculate my x position, well then, like, that means that my value can't just be static. It can't just be a single number. It needs to, I need to store a function that gets used to recalculate that x position, right? And so a computed is just a wrapper type around just that. Like I'll show how that looks too. Computed. It's effectively just it's a signal. Honestly, it's a type of signal, and if you look at, like, a computed stores a computed node. It's just to make it a little opaque. That's not super important unless somebody cares. But it stores a computed node, and a computed node is inheriting from signal base, and signal base is what's doing all of the work to do all, like, the registering of the dependencies and stuff like that. So a computed is literally just like a type of signal that can also run a computation to figure out its own value, right? And so, like, if I want to get a computed, like, let's say I want to get the value of x, but x is a computed, what I need to first do is I need to run the function that would calculate the value of x. Now, if this is where the performance improvement comes in, right? If I just run this function every single time I try to get the value of x, I'm going to be running a bunch of functions like over and over again for a value that's maybe not changing, right? Like if I've already accessed x once in this frame, it's probably not changing unless something else has affected it to change. So I can cache that, right? So what the computed node does is it has a run function, and then that run function effectively allows you to you can, when you create a computed, you can specify a lambda that gets called during the run function. So anytime someone tries to use, like, to get the value of a computed, so like if someone tries to get the value of x here, right, it's going to use this operator function here to get the actual value, and then that in turn just calls this get function, right? And the get function will call node run, right? And node, if you look here, right, it's a shared pointer, and it points to a computed node, right? And a computed node has a run function, right? Okay. Jeez, my nose is really itchy. I don't know what is going on. Computed node, yeah, a computed node, and then the computation is what has the run function on it, right? And I can show the implementation of that later, but it's not super important. Now we call node run, and then that run will in turn call the actual function that is used to calculate the that property. So like Lander style sheet, for example, right? Like this function here for like padding, right? This lambda is stored inside of a computed, or like even for y, right? Like this function is stored inside of a computed, and then whenever we want to get the value of y, we'll call this function, right? But if we've gotten it once before, we can cache this value. We don't need to recalculate it every single time. We cache it the first time, and then we can keep track of the things that this function is using to calculate its position, right? Like to calculate this y, what are we relying on? Well, we're relying on the element's own height. So we need to track, okay, like this y tracks the element's height position, or the element's height property. Cool. And then the other thing that it relies on is the screen height, right? So that means that the screen height also needs to be a signal. So this one lambda relies on two different things. It relies on the height of the screen, and really the window, the height of the window, and the height of the element. And 4 is just a static number, so that's, that's not going to change. We don't care about that. So as long as we track the height as a computed, and the height and the height of the element and the screen height as signals, then whenever the screen height changes, it will notify the y property of whichever element is tracking it, and then that y property will know to recalculate itself. But otherwise, right, we can just return the node value. So like I'll show the implementation of computation here just because it's probably useful to know. But if we look at the run function, right, if not dirty, and dirty is just a flag to determine like whether anything that this node relies on has changed. So like, let's say the screen height has changed. When we call that notify, when we notify this element that, hey, the screen height changed and the screen height is something that you rely on, it'll actually call this mark dirty function. And if it's already dirty, we don't do anything. But if it's not dirty, we mark it as dirty and then we add it to a dirty queue, right? And then we only need to recalculate anything that's in the dirty queue. So effectively, yeah, when we call run, what happens is, hey, if it's not dirty, just return. There's nothing to do. There's no reason to rerun the lambda in there if the actual like value, like the thing that the value relies on hasn't changed. We don't need to recalculate it. So if it's not dirty, just return. No need to recalculate it. It becomes a no op, right? And then we just return node value in here, right? But if it's not dirty, then that means, okay, like something has actually changed and we need to actually go and call like the lambda that is going to update the code. So then that calls this underscore run function, which is back over here in the computed node. It's like this underscore run. And then effectively what we do is we call fn, right? Fn is the function that gets passed in when we define the computed. So we define the computed here, right? Like here, y, this lambda is the function that's getting passed in. It'll get passed into the computed node constructor. It gets stored, whatever. When we call this underscore run function, it'll actually call the function, the fn that's stored on there. And that it needs to return a number, right? Or it needs to return a value of whatever the type of that property is, right? In this case, we're calculating a y position, so it needs to return a number. Okay, so in this case, we return a number from the function, and then we compare. Okay, hey, is this new value? Just because the thing that this function relies on changed doesn't mean that this value will actually end up being new, right? Because like you might say, all right, like if the width of the parent element is 75% or greater, then I'm going to make this element's width 50 pixels. And if it's 74% or lower, I'm going to make the width of this element 10 pixels, right? There's a pretty wide range of values where that element, the parent element, can change, but it won't actually need to trigger a recalculation here, right? Because like let's say we went from the parent element being 80% of the screen width to 85% of the screen width. Well, is that actually going to change the value? No, right? Because we said that anything above 75%, it's going to stay the same. Cool. All right. So if it's going to stay the same, then we don't need to notify anything that relies on it, because this value effectively didn't change. Like, yes, we paid the cost of recalculating this one element property, okay, but the value didn't change. Then we can just leave it right here, because the things that care about this value only care about it changing. And if it didn't change, well, there's no need to like notify anything, right? Otherwise, if it did change, cool, the value becomes the new value. And then invalidate subscribers will actually send a message to all of the things that care about this value, right? So that's kind of on the surface level. That's how the UI library works. So now I hope maybe that will illustrate a little bit why these UI bugs are happening that I'm working through right now. Because like let's go look at the lander thing that I was showing before. I'm gonna just show it one more time for anybody that's just joining the stream now. I'm gonna show what we're about to work on. So in the game, working through this UI stuff. This, among other things, this here is off, right? Like this altitude meter, the ticker should be on the left side of this this line, right? And it's not. And the reason it's not is because right now the Y position is relying being recalculated every single time, but the as I've been reworking the UI system to be more reactive. Remember, this was an existing system, so I'm just porting it over piece by piece. So I started with the X property. So the X property is just being calculated incorrectly right now. The X property should be calculating to be over here, but for some reason it's over here. So I that's what I need to dig into. Like, what's going on here that's actually making it so that the X property is not recalculating when it should, right? Um, we're a little bit over time for the stream right now, but I think I'm just going to chug through along for a little bit longer, see if we can at least diagnose the issue. And then maybe I'll see, depending on how painful it is to fix. Maybe I'll fix it on stream. If not, maybe I'll just do it on the next stream. But yeah, regardless, let's chug through this. So, okay, that I happen to remember that that altitude meter is the actual element for it is inside of sticky flight HUD.hpp, right? And inside of there, I'm going to look for altitude, right? Because there's the altimeter. So there's a function called mount altimeter, and that is what's doing the actual job of adding the elements into the tree, right? The UI tree. So this is where we want to focus, right? Okay. So the lines are fine, the text is fine. Really, what the issue is that there is this arrow right here, right? The altimeter text along with the actual arrow that's showing where the altimeter is, right? So this is using styles altimeter arrow, right? So I also happen to remember that the styles for this component are in Lander style sheet. So I'm going to take a look at Lander style sheet, and I'm going to try to find altimeter arrow. So altimeter arrow, there we go. We got it right here. Okay, so here we can see this is how the X position is calculated for the altimeter arrow, right? We've got, it's a calculated, right? So that means this is going to be a computed property. And it's effectively just taking the element's text width, right? Element get text width, and returning that like negated. So if the element text width is, let's say 50 pixels, we're going to get negative 50 here. Okay. So why is the X position in the wrong spot? Like, in theory, this seems pretty simple, right? It's whatever the width is, we just negate it. Boom, that's the X position, and that's it. Okay. The problem is the X, if you remember, if we go back to the UI element, the UI, the X is a computed, right? So let me look for, I'll just look for X. It's going to be a lot, actually. Let me just see if I can hop down to it. Oh, actually, it's going to be in the HPP. What am I doing? UI element HPP. Okay, so X is computed, right? Which means X only recalculates when the thing that it relies on changes. Well, okay, what does it rely on? It relies on, well, the number, -1 isn't a signal. It's just a number. There's really nothing for us to do there, right? Okay. Then the text width, though, that is something that can change, right? Now, it maybe doesn't change for some elements, but for the altitude meter, the altimeter, it actually does, right? Like as you get higher up, you might be at like 50 meters, then you'll go up to 300 meters, right? And then you'll go up to 1,000 meters. So the width of that text is actually changing. So this needs to be getting recalculated. But if we look at what get text width does, it just returns text width, right? Okay, nothing fancy. But how is text width being calculated, right? So let's look for that. So we saw there's a calculate text width function. There's a render text function that's getting called by something, right? And we know that, okay, if there's a few branches here, but depending on whether the text gets resolved to being an empty string or whatever, it'll start with a different like text width, right? So okay, here we start with does it have an override for the text width? This is not super important. Or we calculate text width. Okay. Well, what does calculate text width do? Okay, it uses the typography manager to actually figure out what the width of the text is, depending on the font size and the font family and all that stuff, because we need to know the pixels, and all we know is how tall is the font, right? So we need to know, okay, what's the actual width that the text takes up? Um, that's a problem though, right? Because text width, if you look over here, is just a float. Okay, so if it's just a float, then when it changes, if text width ever changes, the the thing that relies on it, which in this case was our X position, right? Like over here, our X position relies on the text width, but the text width itself, that element is not a signal. And so if it's not a signal, it'll never get recalculated. If it's not getting recalculated, then anytime we render the X position, or anytime we render the altimeter arrow, the position at which we render the altimeter arrow is going to be wrong because it's going to be based off of whatever the initial text width was. And let's say the text starts off just saying 0 meters. Well, then the position of the X position of the text is always just going to be like at the -0 effectively from wherever the origin point is, which is wrong. Um, so I think what might help fix this is if I change this and just I wrap it in a pulse computed instead, that might just work. And let me see, I don't think I can, yeah, I don't think I can define a pulse computed inline like that, which means that I also have to go and make some changes inside of UI element CPP, right? There's when the element gets created, any of the, and I have to like clean this up a little bit, but for now, like as I'm testing this, I want to just, the way I write code is I make it work first, then we polish it and make it better, right? So you like X is a computed, and X already is when the element is being initialized through the constructor, it's already uh, getting set a default value, right? In this case, we basically pass it a lambda and we say the default value of X is going to be a computed function, and it's going to look at the reactive styles that were passed in. This is not super important right now, but we have like the UI styles, which are like the style declarations, and then the reactive styles, which are the actual like values effectively, or like the actual functions that are being used to actually calculate the the element styles, right? Okay, so we get computed X by saying reactive styles.x, and then we say, all right, if this element has a parent, and the element position is relative, then whatever X we computed is going to be like increased by the parent's X and whatever. This is the actual part of the code that'll make it so that that every X position of every element is padded by, or like is offset by where its parent is. This is how we get like that relative nesting stuff. But that's the X position, right? For the text width, we also want to initialize it, right? Because we don't want to have it be some uninitialized random value, right? So we can give it its own lambda. And so text, I'm actually now I'm starting to think like, does text width need to be a computed, or does it just need to be a signal, right? Because text width will change. And we do have a calculate text width function, so maybe we do want to base it off of the, yeah, sorry, I'm just trying to think here. Maybe we do want to base it off of the actual calculate text width function. So okay, so we have text width equals this new lambda that we have here. And honestly, I think effectively what we want to do is just calculate text width in there, right? Let me see. Effectively, this is what we want to do. Yeah. Render text. I mean, we're kind of already doing it, to be honest. Eventually, I think the best way to do this is to have text width be a computed that subscribes to the text signal itself. There's on here the element has its own like text thing, which can also be computed. So like if the text changes, then the text width should be updated right away. I think that's actually probably what we want to do. Yeah. Okay. So honestly, I think I literally for text width, I think this is what I want. I think we want to do, for now at least, we want to see, okay, is there a text width override? Or if not, then we'll call that calculate text width function, right? And then we will return, we just want to return that actually. So we'll return calculate text, that with calculate. Okay, cool. What is this complaining about? What doesn't assigner? Yeah, assigning float from incompatible type float. Okay. Well, let me see. It's saying that the lambda is returning an incompatible type. Assigning to float. So it's saying, oh, I think it's because I didn't save text W maybe in the HPP. Yeah, there you go. I just forgot to save the HPP file. So because it was like, hey, you're trying to set lambda, like a float variable to hold a lambda, which obviously doesn't make any sense. So anyway, so we initialize text width to just be this computed function. So like now, whenever we need to get the text width, it knows, okay, I can figure that out by calling this calculate text width function, which effectively will call get text content under the hood, and that calls like return text, right? But text itself is a computed. So if now what happens is text like the text width calculation ends up becoming dependent on the actual text itself. So when the text changes, the text width knows that it needs to be recalculated, so it'll get recalculated, um, and then it'll get updated. At least that's what should happen. Um, that might be enough to fix the problem. I can try building and seeing. I have an error in here somewhere. Yes, okay. Because in here, I'm setting text width. This is what was happening before, right? Text W. There's a lot of like not exactly weird. This stuff makes sense for like how it used to work, but it's not ideal anymore. Like there's cases where like the element width gets set to the text width if the parent only has text inside of it, or something like that. Yeah, like the take as much space as it needs, whatever. I'm gonna just try commenting this out for now and see how that behaves. Let me just build. Okay. I didn't change too much, so hopefully it won't take forever to build, but it might take a few minutes here. In the meantime, does anybody have any questions? I know I talk pretty fast and I've been like throwing information at the wall here. Ooh, damn. Translation unit is being compiled for target. PCH file. Oh, goodness. Okay. Yikes. This is gonna result in me needing to do a fresh build. Basically, I updated my Mac OS version earlier today, and I have a PCH file that was generated for that version of Mac OS, and I haven't built the project since I updated, I guess. And now I'm trying to build it, and it doesn't like the old PCH file. But I basically have to like clean out my build and run it again, and that's probably gonna take a little while. And we're already over time here, so I think I'm gonna probably call it here. And we'll pick back up on other time. I'm gonna be doing the same stuff again because this has been a long time coming with all this work. And yeah, it's just I'm probably gonna be working on this same exact kind of stuff for weeks. There's a bunch of like bugs like this that need to be ironed out. So I'm sure there's gonna be more of this for next week. That being said, thank you so much everybody for joining the stream. It was awesome talking to all you guys. It was awesome getting to know some of you. Um, Thanks for the time. I'll be streaming again next week, same time, 10 p.m. Eastern, whatever time that is for you. Um, you know, try to make it. It was awesome to see you guys. And I'll catch you guys next time. Thank you.